Hello, dear students. Today we're going to share or we're going to discuss a new topic that is nothing but the measures of central tendency. In that, we will be dealing with the different measures of central tendency, which is included in your syllabus of computational botany. So, what are the measures of central tendencies? So, measures of central tendencies, they are basically of three different types that we're going to learn today. So, measures of central tendency, what is that actually means? The measure of central tendency is a central value. It is a central value. You can see it is a central value which represents the entire distribution. So, whole distribution is represented by a central value or a representative value. That value is called as a measure of central tendency. Now, what are the characteristics of measures of central tendency? It is the representative value of the entire data set given, and it is a value which represents the entire data from statistical point of view. Okay, so measure of central tendency means a one value. That value will going to represent an whole data set or entire data set. Okay, so there are basically three different types of measures of central tendency. First one is mean, second one is mode, and third one is median. So we're going to see all of these in this lecture, but due to time constraint, we will not able to complete it. So now these are the three different types of measures of central tendencies, but we have to study it for three different sets of the data or three different types of the data sets. You know all, you might be knowing that the data set is grouped into three different types. First one is ungrouped data set, second is group data set, but it is with the discrete series, and third one or the last one is the group data set with the continuous series. For these three different types of data sets, we are able to calculate these three different types of central tendency. So first of all, we're going to study first measure of central tendency, that is nothing but the mean. So that mean is nothing but it is the average value. We have already seen in during our school level that how to calculate the mean. So that mean is nothing but it is the average value of the sample or the population. Sometimes it is called as the arithmetic average. Sometimes it is called as the arithmetic average. So how it is defined? It is defined as a ratio of sum of all the observations of the data set divided by the number of observations. Now, if we see the formula for mean can be represented by the formula like such as x bar. X bar represents the mean or the average. So x bar is equal to summation of x upon n, where summation of x is nothing but the sum of all the observations of the data set. And what is n? N is the number of observations of the data set. Now, what are the advantages of the mean? It is very simple to understand. It is suitable for the further algebraic treatment, means we can use the mean for the suitable algebraic treatments. Then it is least affected by changes in the sampling. Okay, it is not going to affect too much by if the sampling going to change. It takes all the data sets values into the consideration. What are the disadvantages? Disadvantages is what? It is highly affected by the extreme values. For example, if you take 1, 2, 3, and find rate, and if you are asked to calculate the mean, so it will they obviously going to affect your mean. Oh, and second disadvantage is what? It cannot be determined by the mere or just observation. Okay, we have to calculate it. Now, how to find the mean? Just first of all, you have to